Hey guys, welcome to the virtual wire session part 2. In the previous session, we have talked about the basic concepts of the virtual wire. So, virtual wire basically is a transparent mode Palo Alto firewall where we don't need to configure any network or the information of the interface like IP address or VLAN. But the firewall essentially moves the traffic transparently from one port to the another port, which is configured as a virtual wire. So in this particular video, we are going to talk about some of the important concepts from the virtual interface, from the virtual wire interface. So let me correct myself. So there are 5 different topics that I have gathered for you from the docs.paloaltonetworks.com website. So this is the website that I have already shared with you, where you will have the ton of the documentation regarding the Palo Alto firewall concepts and configuration. So let's jump into our slide. So these are the 5 different points. So beginning with the first point is layer 2 and layer 3 packets over a virtual wire. So this essentially telling us that how firewall handles the L2 and L3 packets when it comes to a virtual wire interface. Second point talks about the aggregated interface for the virtual wire. So essentially it is something like you can club 2 or more interfaces to act as a single logical virtual wire interface. It's like your regular port channel, like LSFP port channels or MACD port channels in the switching environment. Third point is the VLAN tag traffic. So when you configure the virtual wire as an interface type in the Palo Alto, by default it will pass all of the L2 and L3 traffic. So it will also pass the VLAN tag traffic. Essentially tells us that what kind of VLANs traffic that needs to be passed from one end of the firewall, that is one interface, that is one virtual interface, to the other. So if you apply some filters, like I want to filter the traffic for 1 to 10 VLAN, or I want only the traffic to be sent from 100 to 200 VLANs, not the others, then you can apply those filters in the virtual wire object and apply that object to the virtual wire interface. So this way you can control the traffic which is to be passed from the firewall and which is not to be passed from the firewall. Okay, so we are going to see all of these details in a practical. Now let's talk about the 4 and very important point from a service provider organization standpoint. So this is a very big concept. Virtual wire sub-interfaces essentially tells us about that you can use virtual wire sub-interfaces to identify or separate your customer identification. So from a helicopter point of view, you might not be able to understand it, but when we go actually in very detail about virtual wire sub-interfaces, then you will get it. Fifth point is how do we configure the virtual wires. So we are going to talk about all of these points in a lab again. So you will have a very good understanding all over these 5 different points. So let's talk about the first point. So there are a couple of points that needs to be discussed. I have separated those points from the docs.paloaltonetworks.com and copy here in my slide. So let's talk about them one by one. So first point says the packets, L2 packets and L3 packets are passed transparently as the policies applied over the zones. So if your virtual wire interface are a part of zones, it is necessary to be, or it is recommended that your virtual wire interfaces should also belongs to zones, but it is not necessary. If they are belongs to zone, then you need to have the security policies configured to allow or to pass the traffic over these interfaces. If your policy is denying the traffic, then the traffic gets denied. When we talk about the L3 packets traversing over the virtual wire interfaces, we need to have the respective policies to allow these packets to pass over the virtual interfaces. So let's take an example that how a firewall acts as a transparent mode when we configure the interfaces in the virtual wire. When you do a trace route, every L3 hop is counted, and when the hop is reached, the TTL value gets incremented. You know how the trace route works behind the scenes? I'm considering that you are aware of that, and every other hop, the L3 hop I'm talking about, is decrements the TTL value in the packet and sends it back as a response. So in case of transparent mode or the virtual wire mode in Palo Alto, it does not decrement your TTL value. So essentially you won't be able to see your firewall in the trace routes. The third point talks about the BPDUs. So these are the essentially L2 packets, which spans across your switching environment and elects your footprints, right? Which helps to decide the other switches in the network domain, to define what are the root ports, what are the designated port, what are the blocking ports, avoid the spanning tree loop in the topology, right? So to allow these packets pass through the virtual wire, you need to allow untagged traffic, because this is a DTP traffic and DTP is not a track traffic, so it is holding a VLAN tag as 0. So if you want to allow these traffic, then you could either specifically specify it in the filters, or you could just leave the box as empty. So by default behavior is to transparently pass every traffic over the virtual wire interface. So in case of L3, if you want to send your protocol traffic like BGP or OSPF, then you need to have security policies in place to allow these protocols traffic traverse from one interface of the virtual wire to the other. In case of multicasting, if you enable the multicast firewalling for a virtual wire object and apply it to a virtual wire interface, the firewall inspects the multicast traffic and forwards it based upon the policy rule. So if you don't enable the multicast firewalling, the firewall simply forwards the multicast traffic transparently.